Again, welcome to Python programming language. In this lectures, we're going to introduce object-oriented programming concept in Python. Again, this is lecture number 9. So our main objective is to describe objects and classes and use classes to model objects. Also, we are going to define the classes with data fields and methods. We are going to construct an object using a constructor. Also, we are going to use the UML graphical notation. The UML stands for Unified Modeling Language, which consists of around 14 different models that we can use to design software applications or software in general. Also, we are going to apply the class abstraction and encapsulation to software development. So we start with the object-oriented programming concept. Here we say object-oriented programming involves programming using objects. So an object represents an entity in the real world that can be identified. For example, a student, a desk, a circle, a button, even a loan can all be viewed as objects. Also in Python, an object have a unique identity, and also it must have a state and behavior. Every object have two major items, which is the state and behavior. The state will be the data members. The behavior will be the methods or the functions. So a state of an object consists of a set of data fields, also named as properties. Or we can also say the characteristics of the object. For example, an employee is an object. One of the characteristics of an employee is that he have an address, he has a last name and first name. Then the behavior of employee can be calculating his salary or checking if it's absent today or present today. So the behavior of an object is defined by a set of methods. So this is an example of a class. Here we have a class named a circle. So a circle, the data phase or the characteristics of a circle can be the radius, and also the methods. Example here can be get area, which is to find the area of a circle. Parameter also can be a behavior or the method of a circle, which is to find the parameter of a circle. So that's the concept of a class. A class always consists of two items, the data fields and also the methods. So this will be our main class definition, or we say the class template. Now, if we are writing a code in the main method, we are going to create an object from the class. A class doesn't have no memory space, nothing. It's just the template. But now we can use the template to create an actual object of a type circle class. So we have a circle object 1. The radius is 10. We can create as many objects as we want. So here we have a circle object 2. The radius is 25. Circle object 3. The radius is 125. So here we say an object has both the state and behavior. The state will define the objects, such as the properties of the object or the characteristics of the object. And then the behavior defines what the object does. For example, to find an area of a circle or the parameter of a circle. So we said in Python, class uses a variable to store data fields. So again, in Python, the class will use variables to store data fields and also defines methods to perform the actions. So additionally, a class provides a special type method known as the initializer. Anytime we create a new object, initializer method will automatically be called to initialize the attributes or the characteristics of the new object. So for example, if we are creating a circle object and the radius is 10, Initializer automatically will create the object for us and assign the 10 as the radius of the circle object. And this method is automatically invoked in the main method when we create a new object. So an initializer can perform any action, but the initializer is designed to perform initializing actions, such as creating the data fields of the objects. So in Python, to again define a class, we start with the class keyword followed by the class name. Then we may have the initializer and other methods also. So let's see an example here, a circle class, how it will look like. So a circle class, in this case, we are importing the math package or the math library file because we are going to use the mathematical functions. So we create a circle class. So we start with the keyword class and the name circle, and with a column. Now we have a comment here, constructing a circle object. So first we need our initializer method, which is the init. Then we have self. We assign radius as 1. So this means when we create a new circle object, the radius of the circle will be 1. Then we assign the radius to self.radius. Next, we can also find the parameter of the circle. So get parameter, and we're going to return the formula 2 times the radius times the par. So this is the reason why we import the math class so that we can use the par function or method. We can also get an area. The area will be the radius times par again. Now to get a radius or to set the radius, we assign the radius value to self.radius. We can also get the radius by returning the radius. So this will be our class circle. Again, this is the template. We haven't created an object yet. We are not in the main method yet. So always when we create a new class, we always start with the initializer method. Initializer method is almost the same concept as a constructor in Java language, a method that automatically calls to initialize a new object that has been created. So again, here we have the test circle. So let's see the test circle also. So here we are going to have the main method. So here we import the circle class. So we have from circle import circle. Then we have our main method. In the main method, we create an object named circle1 from the circle class. Then next, we print the area of the circle of a radius will be the object circle1.radius. Anytime an object wants to access either the data methods or the data members or the methods, we have to use the period, which is the access specifier. So here, object name circle1.the_radius or circle1.getArea. So here, circle1.radius will print the radius of circle1. Then circle1.getArea, since circle1 type is the circle class, the circle have a getArea method, the circle class. So it's going to use it to find the area. Next, we create a circle object with a radius of 25. So we assign 25 to our new object. We assign it to circle2. Then here we say the area of the circle of radius is circle2.radius is circle2.getArea. So here we print the 25 and also we print the answer, which is 25 squared times r. We can also create a third object. This time, the radius of the third object will be 125. So we have circle 125, we assign to circle 3. Then we print the area of the circle of radius is circle 3 dot radius is whatever the get area will give us for the area of the circle, which is the power r square. Now we can also modify the circle, the radius. For example, we know circle 2, the radius is 25. We have circle 2, circle 25. We change it to 100. So we assign circle 2 dot radius equal to 100. And this time the area will be based on the radius of 100. Then we call the main function. So we have the main method with open parentheses. So if we run this program, we are going to create our objects. So first, the program import the math module or the package. Then the program loads the definition of the circle class to the memory. So this is our circle class, will be loaded to the memory. Then next, the program loads the definition of the main function to the memory also. Then from here, the program invokes the main function. So when you invoke the main function, first thing we're going to do is to create the object. And the object name is circle1. So we assign the radius is 1. Here we can enter the amount. They say wrong. Why is it wrong? Because the radius is 1. The radius is 1. Intentionally enter the 2. So now we click next again. And this time the radius is 25. Let me enter the actual amount if they prompt me. So that's 25. Then we go to the third one. So here we have 125 for the third one. $125. The object is assigned to the reference, and the statement will display the circle radius and the area of a circle. So circle radius, whatever the value is, and the area of the circle. And the program finish, we can restart. So constructing objects, we say once a class is defined, you can create objects from the class by using the following syntax, which we call the constructor. So we may have the class name and the arguments. Here, the class, it creates an object in the memory for the class. And also it's going to invoke the class's initial method or initializer to initialize the object. Then the set parameter in the initial method is automatically set to reference the object that was just created. The effect of constructing a circle object using circle 5 is shown below. So if we use 5 as our self, it means we create an object for the circle and we assign 5 to it as the radius. We also have the instance method. So these are methods that are functions defined inside the class. Now, that's the difference between method and function. A function normally is a standalone group of instructions or statement that perform a specific task. But methods always belongs to a class, always. So they are invoked by the objects. So that's why we have circle1 dot get area. Get area is the method because it belongs to the circle class. And in order to invoke it, I have to have the object dot or period and whatever method. So for this reason, the methods are also called instance methods in Python. And you probably notice that all the methods include the initializer have the first parameter self. And the first parameter as self refers to the object that invoked the method. And you can use any name for this parameter, but by convention, we use the term self. So after an object is created, you can access its data fields, and also you can invoke its method by using the dot operator, as we saw here, like c.getParameters. First, we create the object c, which have a radius of 5. So here we can say c.getParameter, or c.getRadius, or c.getArea. So the question is why we use self. We should know that the first parameter is special, and it is used in the implementation of the method, but not used when the method is called. So what is this method self for? Why does Python need it? Now, the self is a parameter that represents an object. So using self, you can access instance variables in an object. And instance variables are for storing data fields. So each object is an instance of a class. And instance variables are tied to specific objects. So each object has its own instance variables. You can use the syntax self.x to access the instance variable x for the object self in a method. And this is our UML diagram for the circle class. So the UML diagram, normally a class consists of 3 rows. The first row will be the name of the class. In this case, is circle. The second row will be the data members or the attributes of the class, which in this case is only radius. The data type is float. Then we have the behavior of the class, which will be the method. So here we have a constructor, circle, radius equal to 1 float. Then we have get area. We also have get parameter. And we also have a set radius. So those are the 4 methods that the circle class objects can use. So again, that's a class name, the data fields, the constructors, and their methods. So from here, we create a circle 1, which is an object of a circle. The radius is 1. Circle 2, the radius is 25. Circle 3, the radius is 125. Now, defining the classes and creating the objects. Here, we give an example of a TV object. We know the characteristics of a TV can be the channel, which is in int, and also the volume level, which is initial, so int, integer. When we say int, we mean it's a whole number, integer. Then we have a Boolean method that will set it to on or off. By default, we set it to on. So we have the TV class. We also have the method turn on, turn off, get channel. Get channel is using empty parameters, and then set channel. The channel will be set based on the argument. Then get volume, then set volume. Channel can be up or down. Volume also can be up or down. So let's see how this class works. We have the class named TV. Always we come with the initializer first. So we have the initializer, and all the attributes must be initialized here. So the channel is 1, volume level is 1, and force is 1. So here we initialize all the 3 attributes of the object TV. Self.channel1, self.volume level, and self.force on. Next, we have a method to turn on the TV. So this will we assign true to on. Then next we need to turn off the TV. So we assign self.on to false. Then we need to get the channel. So we return self.channel. Then we need to set the channel. So self.on. If self.on and self channel is less than or equal to 120 or greater than or equal to 1, then we have self.channel equal to channel. And this will set our channel for us. Now to get the volume with self.return the volume level. So return self.volume level. And the same thing apply to channel up. We say if self.on and self.on channel is less than 120, then we assign self.channel equal to self.channel plus 1. Then we can get the channel down, which is if self.on and self.channel greater than 1, we assign self.channel to again 1. Next will be the volume. So here the volume, we say that if self.on and self.volume level is less than 7, then we assign self.volume level equal to self.volume level plus 1. Then the volume down, we say self.on and self.volume level greater than 1, we assign self.volume level equal to self.volume level minus 1. So that will be the function, and this will be the definition of the class. Now in the next section, we are going to test the TV class. So here in the main method, we have object TV1. We create the TV1 object by using the TV template class. Then we set the TV1 on. We set the channel to 30. We set the volume to 30. Next, we create a second TV object. We turn it on. We set the channel up. And then we set the volume up also. So now we print that TV1 is channel is TV1.get channel. And volume level is TV1.get volume level. And TV2 channel is TV2.get channel. And volume level is TV2.get level. Then we are going to call the main method here to start to work on it. So we have what we call the mutable object versus mutable object. And this is the trace of it. So for example, here we have we create the circle. The size is 5.0. So the second circle is 1.0. Then third circle is 100. And we create the reference also. So designing guide, here we say that if a class is designed for other programs to use to prevent data from being tampered with and to make the class easy to maintain, we need to define the data fields private. If a class is only used internally by your own program, then there's no need to encapsulate the data fields. So class abstraction means to separate class implementation from the use of the class. The creator of the class provide a description of the class and let the user know how the class can be used. Also, the user of the class does not need to know how the class is implemented. The data of implementation is encapsulated and hidden from the user. So defining the class loan, Here we have the name of the class, the first row. The second row, we have all the data or the attributes of the class loan. The annual interest rate, the number of years, loan amount, and also the borrower. The second item on the right side is just the data type. We also have an example here for BMI class. So the name of the class is BMI, first row. Second row, we need to have all the data members. We have name, age, weight, and height. Now we need to have some methods. So for example, we can say get BM and also get status. And another one, date time class. Again, the first row is the name of the class, date time. And the second row will be all the possible attributes of the class. And then the third row will be the methods. So procedural versus object-oriented. Here we say in procedural programming, data and operations on the data are separate. And this methodology requires sending data to methods. Object-oriented programming places the data and operation that pertain to them in an object. And this approach solves many of the problems inherent in procedural programming language. The object-oriented programming approach also organizes programs in a way that mirrors the real world, in which all objects are associated with both attributes and activities. So using objects improve the software reusability, and we will talk about inheritance, and also make sure programs easier to develop and easier to maintain. So programming in Python involves thinking in terms of the object, and a Python program can be viewed as a collection of cooperative objects. So that will be the conclusion of our lectures. And again, I wish everybody the best for the final exams. Thank you.